Okay, so we're working on Lesson 8, part number 10. That's the part we're going to be looking at. And if we take a look at the print here, this is the CAM instructor print that we're working with. We've already went ahead and the students have plotted the points, so you should have those ready to go. And what we're going to do now is basically we're going to mill this channel out here. So we're going to climb mill around this outside wall here, and then we're going to move down, and then we'll climb mill around this inside right here. That's the plan. Okay, actually I think I got that backwards. I think we're actually going to climb mill around the inside first and then move down and climb mill around the outside. And I'll explain that more when we take a look at our points here in just a second. So let's go ahead and get our program set up in our WinMax software. Let's go ahead and jump back over to WinMax. Okay, I have my Lesson 8 Part 9 still open. So I'm going to use that as a template for this next part, because basically it's very similar to this part, but we're making a few changes as far as the positions go. So let's get started with that. I'm going to go to my software here, and I'm going to go to my program manager. I'm going to start a new NC program, and I'll go ahead and do a save as, and this one's going to be my Lesson 8 part number 10. So I'm just going to change this file name right here, hit enter. Okay. Drag this over. Alright, so there you see I've got Lesson 8 Part 10 ready to go. Right now that's just a blank template ready to work with. And then I'm going to go back to my Lesson 8 Part number 9, and I'm going to borrow some of the information from here, because basically we're doing the same thing. We're milling, we're working with the origin in the center of the part. The Z's set off the top of the part, so a lot of our comments and stuff are going to be the exact same. We just got to do a little bit of modifying. You know, I always tell everybody, and I know if there's anybody watching that's had me in class before, copy, paste, modify. You know, that's our thing we do. Just try to save and make work as efficiently as possible. So I'm going to take everything from the program number all the way down to the first operation comment. I'm going to hit Control-C to copy that. And I'm going to paste that over here into our Part 10 file. So this is Lesson 8, so Program 8, and the part number is 10, so we'll change this to 810. Change our comment right here to Part 10, and then we'll go down through here and make sure everything else looks good. Our safety line, XY plane verification, we're working in inch coordinates, cancel any cutter comp, cancel any tool links, and cancel any key in cycles. So our safety line looks great. We've got our notes here. We're going to set our origin in the center of the part, just like it shows on the print, and we're going to set the Z off the top of the part, just like it shows on our print. So if we take a look at that, we can see both of those, center of the part for our XY and the top of the part for our Z. Alright, so everything looks good. We're using these same tools. We're using Tool 4, which is a 1/2 inch 3-flute end mill. We're going to use Tool 1, which is an 1/8 inch 2-flute flat end mill. We're just going to plunge through this part with that end mill. We don't actually have a 1/8 inch drill set up in this tool library, so we're just plunging through with an end mill. Probably not the best practice, but it's what we're going to have to work with today. So we can see that, Tool 4 and Tool 1 here. Okay, now we're going to do this one more time. We're going to go back to Lesson 8 Part number 9, and we're going to get the information for our tool here. So we'll come back here, and we're going to grab the comment for what tool we're using, Tool 4, which is our 1/2 inch end mill. And I'm going to grab everything down to the approach move where it turns on the coolant right here above the part. Okay, so I'm getting all of this. I'm going to Control-C to copy, and then we're going to come back to our other program, and we're going to paste that in. Okay. We're just using our template programs to work through this. So we've got our Tool 4. It's got the information about the tool here for us. We know which tool we should have in the spindle at this point. T4M6 tool change. Got an op stop here to verify that we put our tool in the correct position. We're going to work in absolute, work offset 1. We're going to rapid to X0, and position 1 is actually where I want to go to. So I'm going to pull my positions up on the screen here. Okay, and we're going to look at that. Now, I mentioned this while I was talking about the print there. When we plotted these points on this print, if you followed along with the way the workbook did it, which is what I instructed the students to do, it actually had you conventional mill both of the walls for that channel. So the way that it was working, it actually had you milling this wall going in this direction, counterclockwise, or actually that'd be clockwise on the inside part, and then moving up and conventional milling along this inside wall here. We want to climb mill those, so we're basically going to do this in the exact reverse direction. So basically, when we look at our points here, we're going to start with position 10. That's where we're going to move to, and we're going to work through to position 1. So we're going to do these in the exact opposite order of what we plotted them out in. All right, and that's just because we followed along with the workbook for the plotting exercise, so that's why we're going to work with that just a little bit backwards compared to what we were doing. So that being said, I'm going to pull those up on my screen. I'm going to minimize my thing here. There we go. That way I can see those still. There we go. All right, so our position 1 that we're going to go to for checking our tooling is going to be negative 1.875 and y 0.875. Oh, 0.75, sorry. 0.75. Start position, we're going to check our tool. We've got our G43 coming down to check the tool length. Tool 4, H4, H&T agreement, looks good. We're coming down at a linear feed rate move at 50 inches a minute to 2 inches above our part. And then we'll have another op stop built in. That way we can check that tool length and make sure that we didn't mess anything up when we set our tool. So as long as that looks good, we can go ahead and from there hit the green button again and turn on the spindle and then move down just above our workpiece and turn on our coolant. Okay. Once we've done that, we are ready to start milling around this part. So like I said, we're working backwards, so our next move after we get to depth here is going to be to move to 0.9 here. So the first thing we're going to do is we're going to come down to depth. So we're going to come down to Z minus 0.125. That channel is an 1/8 inch deep if you look at your print. And then we're going to do a G1 over to X0 and our Y should not be changing here. Let me look at this. We are at 0.75 and we're moving straight over. Our Y does not change. Okay, so that being said, this Y right here on this print on the answer key is incorrect. That should be 0.75. Okay, so position 9 should be 0 point and then 0.75 here. So the Y shouldn't be changing. Nothing like finding an answer key issue while you're live on the stream here. Okay, moving on though, now we're going to go around this part. Okay, we're going to go around. We're sitting right here. We're going to mill around the outside here. So that is a clockwise move going to 0.8. So that's going to require a G2. G2. Our X value is not changing. Our Y is moving down to Y minus 0.75. And then we're using I's and J's right now. So if we look at that again, we go back over to our part print, the value from the start of rotation, which would be right here, okay, right here, to the center of rotation. Okay, so the center of the tool, it's a 1/4 inch tool, so if this is 0.75 to the center, that's in the negative Y direction, so that's a J negative 0.75. So that's what we need to put in for our radius value, a J negative 0.75. And we can go ahead and, we could have done this here, we should have turned our feed rate up to 93 here for that tool. We're milling aluminum, if anybody's wondering out there, so our feed rates might seem a little excessive in this case. And we'll go ahead and take a look at this and just make sure that so far we're on the right path. We started here, We've milled around, got to here, and then we just did our arc move, and now we're going to do a linear move back out of the part and then move down and mill around the outside of that contour. So that's our next move. We're going to do a G1, and we're moving back to X minus 1.875. Okay. So that's where we're at right here. We're at position 7. We're working backwards. I could be marking these as I go just to kind of help everybody keep track of where I'm at. So we started at 10, then we went to 9, then we went to 8, and then we went to 7 here. Okay, just to kind of help everybody keep track that's programming along with this. From there, we're going to go ahead and move straight down to 0.6. So we're going down to Y minus 0.875. And then we're moving over to 0.5. Okay, so we're moving over to X 0.75. Mark that one there. Okay. And if we draw this now, you should see that we just came over, we moved down, and then we just milled back into the part here. Okay. All right. Now our next move. Our next move is a clockwise arc. Okay, so clockwise, I keep just getting it backwards. I think I don't know how to read time. Counterclockwise arc, sorry. So we're going to do a G3 this time. Okay, and then we're going to 0.4. So 0.4 is X 0.875, Y 0.75, negative 75, sorry. Negative 0.75, and then we need to go and look and see what our I or our J value will be. So let's go look at our print here. Okay, so if the start of rotation is somewhere right in this general area right here, the tool center line is sitting right here, and the center of rotation, let's call it where this hole's at here. It's not quite right on, but let's say it's right here. So it's straight up from the center of the tool, so that's in the Y direction. Now we're on the inside of the arc, so we're going to subtract the tool radius from the actual radius. So if the actual radius is 0.375, that means our I or J value would be 0.375 minus the 0.25 of the tool, so it's going to be a 0.125. So it's in the Y positive direction, so it's a J, it's a positive, and it's 0.125. So that's what we're going to plug in for our value here. We're going to plug in a J 0.125, getting us to position 4. And then we'll verify that in graphics. Okay, so we're sitting at position 4. Now we're going to move straight up to position 3, so I'm just going to plug in a Y 0.75 here to position 3, right? And we'll hit draw. Or will we? Okay, we get an arc out of tolerance error. Okay, and we've talked about this. Okay, this is something that people struggle with the most. It's not getting the points and getting the arc right, it's remembering that we have to go back linear after the arc. Okay, so that's usually where it's going to be. It's going to jump to that line, and we always gravitate to the arc move, thinking that we did something wrong there. We've got to remember that if we were in an arc move, we have to switch back to linear in the next line. Otherwise, it'll throw us a arc out of tolerance error. Okay, the math doesn't add up. We'll go ahead and we'll draw this. Okay, so there's our move straight up. Now we're ready to do our next arc move. Okay, we're going to go another counterclockwise arc, going from 0.4 to 0.3. Okay, so we'll do that next. We'll do another G3. We'll look at our points for 0.3, X 0.875, Y 0.75. And we're going to do our I or J value now. Let's look at that one. So we'll go back to our print. Right now we're sitting right here on the inside of this arc. This was the start point of rotation right here. Okay, right in this area. So once again, we're on the inside of this arc, so we're going to take the tool radius and subtract it from the actual radius. So if the radius is 0.375 again, we'd subtract the 0.25, so we know it's 125 thousandths. From the center of the start point to the center of rotation, it's in the negative x direction, so it's going to be x minus 0.125. So it's going to be, or not x, I. It's going to be an I minus 0.125. So that's what we're going to go back to our program and plug in, because it's in the x negative direction, so it's an I minus 0.125. I minus 0.125. Okay. Plugged in the wrong value for our y here. I'm pretty sure I'm going to get an error here in a second. No error, but if you look really closely at that, you can see it did a big old circle error because I came right back to the same point. Let me plug the right value in for my y here. There we go. Now let's see what it looks like. Tolerance error. That's what I did. Put my 0.875 for my x. So always double check your points. We're going to see a lot of errors. Even here, as I instruct you on it, I'm showing you that I also am human and can commit these errors, but I got to just figure out what my points were and what I went wrong on. So I got that fixed. Okay, there we go. Now we can go ahead and do a G1, back over to x minus 1.875, 2.1. Take a look at that, and there we have milled all the way off the part. Okay, now we're going to take a look at our print, because the next thing we're going to do is we're going to go ahead and drill the holes. Okay, so we look at that. Go ahead and get started here. All right, so on the holes, we've got those plotted already. Okay, I've got those on my points. Okay, we just did a bolt hole circle and done the math for that. So let's go ahead and let's plug those in for where they are at. So I'm going to start out by, first off, I guess we better get this tool up and out of the way. So I'm actually going to go back to my other program and copy most of this. Here we are moving 100 thou above the part. I'm going to take all of this information and we're going to send this tool home through a reference point. So we're going to go 100 thou above the part, still at our feed rate move. Then we'll wrap it up to 2 inches above and we'll shut our coolant off. We'll send it home and shut the spindle off. We're going home through a reference point programmed into the control. And then we're going to bring the table to the center location that's programmed at the control also as a reference point. Once we've done that, we can go ahead and move to the next part of the program. So the next part of the program is actually going to be drilling the holes. So like I did before, I'm going to borrow that from my last program. I'm going to start here with my plunge comment. And I'm going to go all the way down to my can cycle line. Okay, yeah, we're going to change some positions, but that's okay. I'm going to copy all of this. I'm going to jump back over and paste that in. And then I'll modify what needs to be modified. So line by line, I take my time and I look at this. Tool 1, M6, G90, G54, G0. I'm moving to position 1, so that is going to be changed here. I'm moving to X7071, Y7071, and then we'll move down to 2 inches above our part. Check it with our 1, 2, 3 block again, or our touch-off device, you know, or our scale, whatever we're using, but we want to make sure we double check our tool length. We'll turn on our spindle. Okay. And we're still using that max spindle speed of 7750. 100 thou above the part for our initial height, because we're going to use a G98 within our can line. That way it's going to go to 100 thou above in between each hole, rather than going to our R plane. All of these holes are through holes, so if this part's a 1/4 inch, we've got it doing a 25 thou breakthrough. So we're good there. We're good to this point. Our R plane is set to negative 100 thousandths. Okay, we did that on the last program, and we're doing it on this one as well, because we've actually already milled 125 thousandths out of that channel, so there's no reason to start feeding from above the part. And then we've got our feed rate set. Okay. After that, we just got to tell it the locations of the last 3 holes. So X minus 0.7071. Y is not changing for hole 2. We need to tell it the Y minus 0.7071 for hole 3. X doesn't change on that one. And then we move straight over next to X 0.7071 to hole 4, and the Y stays where it was at on the previous hole. So we're just changing either our X or Y as we work around that bolt pattern. They're kind of in a square of each other. Okay. Once we get here, I'm going to jump back over. I'm going to hit save. All I'd want to happen is my computer to crash after I've done all this. And then I'm going to go borrow basically the end of program from the cancel can cycle to my M30. Control C to copy. And then I will paste that into the program over here. And if I draw this now we can see, let me go to a different view here, we can see that we've programmed the part, we've got it milled correctly, there's no blims, there's no rapid moves through the part. That was something we definitely don't want to see. Everything looks good. So we save it, and if you've got it all complete, now you can go on Blackboard and submit that for a grade.